Naka and welcome to the first in our series of training videos on soil health and soil productivity. Soil is the uppermost layer of the Earth's crust, supporting life above and below ground. How soil functions to enable plant growth is vital to life. As a farmer, you need to understand the importance of soil as a living system and ways to manage your soil in order to improve crop productivity. In this video, we will explain the different properties and characteristics of soil, as well as the functions and services soil can provide. Let us begin by looking at the three fundamental properties of soil: physical, chemical, and biological. When you take a handful of soil, the first thing you will notice are the physical properties of the soil. You can feel and see the texture of the soil, which depends on the sizes and type of soil particles. The three particles that make up soil are sand, silt, and clay. Sand are coarse particles. Clay particles are very small and silt are medium. Most soils are a combination of the three, and the relative percentages of sand, silt, and clay are what gives soil its texture. Identifying the correct soil texture can be done with the aid of a soil texture triangle. For example, let us consider a soil having 40% silt, 40% sand, and 20% clay. From the chart, the resultant soil is classified as loam soil. Loam soil, as included in the central shaded area of the triangle, is considered to provide the best structure for the best plant growth. The reason is that these types of soil structures offer the best environment in terms of water capture and infiltration, nutrient retention, as well as enabling air circulation in the soil. The biological activity is the second property and characteristic of soil. It's the ability of the soil to support living organisms. These organisms coexist in a community through a food web system. A food web diagram, as shown, depicts a series of energy conversions and nutrients as one organism eats another. These organisms help decompose dead plants and dead organisms, which produces organic matter that in turn provides nutrients for plants. Some organisms are also vital in converting minerals and chemicals into nutrients that a plant can absorb. The third and final property of soil is chemical. This is related to minerals and elements present as nutrients in the soil, and also the chemical environment such as acidity and salinity. There are 17 nutrients that contribute to healthy plant growth, which are absorbed by plant roots and leaves. These nutrients are classified into two categories. Nutrients that are required by the plant in large quantities is referred to as macronutrients, such as nitrogen, phosphorus, potassium, calcium, carbon, hydrogen, oxygen, and sulfur. And those needed by plants in less amounts are known as micronutrients. These include iron, chlorine, boron, copper, manganese, molybdenum, and zinc. There are 5 essential functions or services the soil can offer. We will focus on 2, but let us briefly go over the other 3 functions as they contribute to the overall health and sustainability of the farm environment. The first soil function is biodiversity and habitat. Here, soil supports the growth of a variety of plants, animals, and soil organisms, usually by providing a diverse physical, chemical, and a biological habitat. Improved soil biodiversity improves the resilience of soils as well. The second function is filtering and buffering. Soil acts as a filter to protect the quality of water, air, and other resources. Toxic compounds or excess nutrients can be degraded or otherwise made unavailable to plants and animals. Physical stability and support is the third function. Here, soil has the ability to maintain its porous structure to allow passage of air and water, withstand erosive forces, and provide a medium for plant roots. Soils also provide anchoring support for human structures. The fourth function or service that soil can provide the farmer is the cycling of nutrients from the air and organic matter into the soil. This is converted into nutrients that can be made soluble in water and absorbed by a plant to make fruits and vegetables. When the plant dies, nutrient can be incorporated back into the soil to continue the cycle. We have discussed that there are 17 nutrients in the soil that promote plant growth. So let us look at the most abundant macronutrient, nitrogen, and how the cycle works for this essential plant nutrient. Microorganisms indicated by the red jelly bean characters first convert atmospheric nitrogen into ammonium, and then converts ammonium into nitrites and nitrates by the process of nitrification. In a similar manner, nitrogen gas can be fixed into soluble form that can be used by plants in a process called nitrogen fixation. Finally, nitrogen is converted back into the atmosphere upon decomposition and decay of dead plants and animals. From this example, you can see how the presence of microorganisms in the soil is very important in the nutrient cycle and provides a natural and cost-effective method to deliver nutrients to plants. Soil organic matter is another nutrient pool in the soil, which is reduced through mineralization by soil organisms releasing nutrients into the soil. The final and fifth function that soil provides is water provision. Soil can have different abilities on water drainage, water flow over and within the soil, and water holding capacity. Water can also dissolve solutes such as nitrogen, phosphorus, and other nutrients and compounds, making them available for plant roots to absorb the nutrients. Part of the soil structure is determined by the parent material of the mineral components of the soil. For example, clay soil tend to make overlapping horizontal layers, while sandy soils tend to be very granular. The spaces where air and water could live line up very differently in these two types of soil. Thus, many clay soils have a tendency to be poorly drained. By contrast, the sandy soil, as in atolls, has almost no structure. The porous areas can shift very easily, and water has a tendency to drain through very rapidly, taking any fertilizer with it. So, for both soils to retain water, adding organic matter is very important. This video has hopefully given you a better understanding of the importance of soil, defined by its physical, chemical, and biological properties, as well as the functions and services it can perform for the farmer. In our next segment, we will look at the different indicators of soil quality and how to test the chemical properties of the soil.